Hi everyone, welcome back again today in our Tech Talk. Today's episode we're going to talk about image recognition and machine vision, or anything to do with visualizing images through computer, identifying images and what we can do with these identified images. It's a very crucial topic. It's related to many other latest technological advancements like AI, machine learning. All of these things do relate to machine vision, because for a computer to do or understand anything, it needs to be able to see. And machine vision, or image recognition, gives the ability for a computer to see and identify objects that are around it. So it is a very cool topic. Not only AI, it expands onto many other things, Internet of Things and other IT tools as well. So yeah, very cool topic to talk about, and I thought our audience will very much enjoy what we have, the experiences and knowledges we've gathered over the years working around this topic. So yeah, let's talk about machine vision and computer image recognition.
Hi Renat. Yeah, I think it's a cool topic, and thanks again for the introduction. Image recognition, computer vision, machine vision. I mean, there are so many terms, and it's a quite a relevant topic because these days we hear about self-driving cars. So they have cameras and they drive recognizing objects in their paths. Then you have surveillance cameras that recognize faces of people. So that's how police or law enforcement agencies detect, I mean, people who are doing harm to others, burglars, thieves, etc. And then you have OCR software. So this is something that reads an image and converts that into a text. So OCR actually stands for optical character recognition. So I mean, normally you have a Word file, but Word file has text, so it's easy. But suppose you have an image of a PDF or a image of a book, the page of a book, and you want to extract text from it. So you'll use something called as a OCR software that will extract the text, put it in a Word format, which you can then edit and use. So yeah, I mean, it has a lot of applications. It's a very exciting topic because it's not just related to day-to-day activities, but computing and other things as well. So yeah, let's dive deep into it.
Yeah, absolutely. So I mean, when we talk about machine vision, or character recognition, or anything to do with digitally seeing things, we first need to think about why is it. So we are trying to, I mean, from like 20 years ago or even 30 years ago, with the advent of computing, we tried to integrate that with our lives. At that time, if you type something in Microsoft Word or a notepad, those are digital text. But then we were also heavily reliant on paper trails. Everything was printed, everything was written down, even a signature was signed on a paper, etc. And then came the scanner. And the first, when I heard about a scanning machine, I thought, wow, this is amazing. This is where the digital world, because we already, with computing, we had computer games, we had computer softwares, and we had a whole world within the computer already. My documents were in, and I always thought, okay, I first came to know about printer, and I thought, okay, anything that I create in digital world, I can bring them to my real world by printing it. And that was it. And I thought, okay, digital world is this small world where I can create things, and then physical world is the real big world with all the rest of the information, and I need the what I created to be printed. And then printer was this one-way communication between the digital world and real world. And then slowly the digital world started to become bigger and bigger, and we started to do more things digitally rather than anything else. Now we even sign a document digitally as well.
Yes.
So as the world became bigger, before it was one-way communication, you print things out, but then how do you take things from a real world into the computer? And then that was the scanner, and I thought, okay, there you go, two-way communication. But then I realized that scanner only scans the document and it saves it as an image. So the computer doesn't actually know the text that I just scanned. It just I understand is as bitmap images. And then there was this need that whatever was created in the physical world, all of these books that scholars and novelists and all of these people have written, all of this knowledge, if they're not available in the digital world, then we can't really make the most out of those information. And if we just scan, then we're not really making full use of that information, because it cannot be digitally read. So that's when this technology evolved, OCR, where you understand the texts that are written in an image. And obviously then it starting expanding into real time understanding of texts or objects in image. And that's how we get machine vision, where it tries to understand in real time, as you said, computers are looking at CCTV cameras and identifying human faces, or even ANPR, automatic number plate recognition. They're
Yes.
trying to identify the text in the number plates and things like that. So yeah, so that's how we evolved and have a smooth transition between real world and physical world by computers' ability to understand everything around real world. Before, able to just initially just read text or just see an image of something in real world, and then more and more, as we started doing more and more things digitally, we needed digital world to be more powerful and be able to talk to the real world in a more smoothly. So because of that, we now there was a need for computers to understand what it understand. There was a need for computers to be able to see what we see, and that's you know the sort of the primary motivator of all of these technologies. OCR to understand the text, image recognition to understand the objects in an image, and then real time camera object recognition, where it understands anything that it can see in a real time video and identify what object is what. With all of these advent of technology, we came to actually see how much more ways we can use this, because before it was just a communication between the digital world and real world. But the more machine were capable of identifying these things, the more we realize, oh, we can use this to create self-driving cars, because now digitally we can understand in real times all the objects that are around us. So from that there, all of these new things emerged, where we found new ways to use this technology. So yeah, that's how we ended up here with all of these new technologies, where the computer is understanding what is around it, basically giving the computer a vision.
Very true, and well put, Rinat. I think, yeah, you've summarized it quite well. So the transition, I mean, the taking data from physical world and putting it into digital world, and taking data from digital world and putting it into physical world. I think you've summarized it really well using a printer and a scanner example. And yes, you're right. It's actually before we jump into the benefits and the applications, I think we should understand how human vision works, and what is printer actually doing and what is a scanner actually doing. So the most important thing is depth. So computers, they record videos which are two-dimensional. It has a length and a height. It doesn't have any depth to it. And human vision has depth. So we can see not just the length and width of a object, but we can also see the depth, how deep it goes. And that's gives us the ability to perceive whether it's close to us or distant from us, etc. And that's very crucial when we interact with day-to-day objects, because suppose we take our hand close to an object near me, and I just pick up a bottle. I know how far is it, but if I just show this to a computer, this particular image that you're viewing now, the computer just sees a two-dimensional object and it doesn't know who is human, who is a bottle, what is behind, is there a mic, is the person wearing a t-shirt, etc. And that is basically very difficult for machine to understand, and we need to train them. So when it comes to paper, as you said, scanning. So we take a paper, two-dimensional object, we have some text on it, and we put it in a scanner. It takes a photo of it. Photo itself is a two-dimensional object, and then it just has no understanding of what the photo contains. And OCR software helps it to recognize text in a particular format, to then be able to identify and then convert that into a digital text that can be edited, because the photograph itself we cannot edit. So with OCR software, we get the ability to extract the text and then be able to edit it. And you rightly said that there are so many books now which are there in the world which has to be scanned, because you cannot just ship books to every part of the world. Computers, they don't understand depth, so we take a image, we scan it, and then computer sees it as a photograph, but it doesn't know how to identify, and OCR software helps it to identify. But what the software is doing is, it has already gone through a lot of text images, and it has an understanding of how each alphabet looks when written in different styles, which is calligraphy. And then it understands, okay, if a T is written in this way, then no matter how T is placed in that photograph, it will always be considered a T, and say A, B, C, etc. And that's how you can identify what the word is and then put it in the Word document or whatever. So yeah, so this is image recognition, or OCR, which is a part of computer vision, because it is just 2D. It's just a two-dimensional object being converted into a two-dimensional object. But what about a three-dimensional object? Like when you're driving a car, we talk about self-driving cars. So if you're talking about self-driving cars, then you are seeing objects on the road which are other cars, humans, cyclists, then animals, etc., other objects, other vehicles, etc. So those are three-dimensional objects, and computers don't know whether it's what that three-dimensional object is. So that's why computer vision is important, because we have to understand how human vision works and then replicate that into computer vision, make the computer understand what the object is, how far the object is, how quickly we are traveling towards the object, and if that object is a human being or a vehicle, how do we avoid it, or how do we interact with it? And that's the big challenge. And the way they do is they take the photo or the video, or the video, which is nothing but a photograph running, um, say 30 frames per second. So it's basically 30 photos being played in 1 second, and a video is normally that. And once you know that, okay, from one photo to another photo, what pixel is changing, and is that pixel changing constantly, or is that pixel fixed? And based on that, you can identify what is there in the image. And yeah, so it's pretty fascinating. So you have to start with a human vision, computer vision, or machine vision, then go down. And machine vision has two aspects: video and photographs. And the photographs is related to OCR, and the video is related to what you see in real life using a camera. So it's pretty fascinating.
It is, yeah, and it's interesting you mentioned about human vision as well, and comparing it to computer vision, because there's one very interesting study I came to know about. Is A study was done by done on blind people who were blind from birth, so they have never seen the world. But obviously, with the technological advancement in medicine and medical industry, there were ways to give blind people sight. Now, if the person has, as I said, has never seen real life before, never had sight, and were blind from birth, after giving them, after they had their operation and they had their sight, for the first time they started seeing the world the way we see. But a lot of cases they were already adults and knew how to navigate around the world, but now they're able to see. Now, Um, what what the study did is they first showed them drawn, a triangle and a square next, on a piece of paper or in a computer screen, and then they showed them that this is what a triangle is, this is the definition of triangle, and that's why this is a triangle, and this is a square, and that's it, etc. Now, if you, as me and you, as when we see a triangle on top, drawn on top of a square, so the triangle and square is drawn in the same space, so they sort of cross each other.
Overlap.
Yeah, they overlap. We would still understand that there is a triangle and then there is a square straight away. Throughout what we've learned over years, we can identify triangles even if it is overlapped or in on top of many other artifacts, other geometric circles and geometric objects. Um, but the blind person who just got their sight back wasn't able to identify triangle and square straight away, even if they are superimposed on top of each other. They would just see different random shapes which are created by the borders of triangle and square with cross section. You would probably see two or three smaller triangles and then an hexagon and that kind of stuff. They weren't able to identify that there were, you know, a superimposition of triangle and a square because they haven't had the opportunity to learn this that we sort of intuitively learn as we navigate around our world. We see various shapes and we kind of can identify what are the important shapes and objects that that are important to us. So even as humans, this kind of proves that we also, after being born, we also see everything in a jumbled way, the way the world is, and then we slowly learn what shapes are important to us, what objects are important to us, and how we can navigate around the world, what needs to be picked up, and things like that. And the blind person couldn't first identify all of this, and then obviously over time they got used to it, their brain started to learn. And so yeah, human vision is just like that. We also go through the learning process that
Yes,
the computer vision is now slowly going through that process of learning.
it is true. And the way they learn is again through a lot of repetition. So suppose I show the photo of a dog or a cat, quite a common meme on the internet these days, a cat photo or a dog photo. So you have a dog, but you have so many different types of dogs. So you try to show a photo of a dog and you ask the computer what it is. And because the computer doesn't know, you say that this picture is a dog. Then you show another picture and you ask the computer what it is. And the computer then uses the reference of the first dog and then says, maybe it's a dog, maybe it's something else. It doesn't know. So you say it's a dog, and then you move on to the third image, and that's how you do lots of images, say millions of images, and you tell the computer that over a period of time you have recognized all the patterns, you have stored it, and every time I've told whether it's a dog or a cat, and you should now, if I show you after say the 1 millionth or the 10 millionth image of a dog, the computer should be able to tell that okay, based on all the learning that I've done, this is a dog. Now, I think you mentioned very rightly that we go through that learning process, but we go through that learning process over so many years, right? With
Yes.
machine learning, the advantage is we can train the computer in a few days,
Yes.
and
Yes.
that's the advantage of using computers because what we learned over 10 years, they can learn in 1 year. All that training can be done because they can run 24/7. So whatever objects that we recognized, say a tree, a branch, a cake, a pastry, a computer, a laptop, road, cars, bottles, glasses, printers, etc., they can all be trained to a computer model. And once that model then gets a new image based on its learning, past learning experience, it can then identify what the object is, right? So again, how do they actually identify whether it's a dog or a cat just by looking at a photograph. Because a photograph in a digital world is made of pixels. So suppose you have an image. That image is say 10 megapixels. So whenever you take a photograph from a digital camera, it says 10 megapixel. Your smartphone says 48 megapixel. So what does it mean? So megapixel means it has, I think mega is 10 power 6. Sorry, 10 power 6 is giga. 10 power 6 is mega, 10 power 9 is giga. So 10 power 6 pixels or 10 million, 10 power 6 is, yeah, 10 million pixels in one square or whatever is the size.
Mhm. Yeah.
So suppose 1280 by 720 we define, so that's the normal size. So people who are watching us right now on this video, they might have the aspect ratio of 16 is to 9, 1280 by 720 or 1280 by 1080. And that's the resolution, that's the size of the rectangle. And in that rectangle, you have 10 million pixels, and each pixel is a dot. Each dot can have three colors: RGB, red, green, blue. And based on the intensity, it has a particular value. And based on the location of that particular pixel and the brightness and the color, and then you apply that to the whole 10 million pixels, you come and see an object. And that object could be a human, could be a table, could be a chair. And then you tell the computer to look and identify patterns. So if a human is there, there'll be a head, so there'll be something round on top. Then they will have
Yes.
shoulders, they'll have arms, etc. They'll have two legs, two limbs. If it's a table, it'll have a certain things. And then you take the image of a table from multiple angles, so you add depth. So it has depth recognition,
Yes.
and that's how you train the models using machine learning and these deep neural networks. I think you have spoken about machine learning and artificial intelligence in one of our previous talks, where you talk about how this training model works, and eventually a computer learns. But now whatever you have learned, you have to apply it in real time, because humans do one thing very well: they recognize an object and they interact with it in real time. So it's not like, oh, that's a phone, I'll take some time to understand what a phone is and then interact with it. No, humans see a phone, they pick it up. So computers should be able
Yes.
to do that, the same thing in real time. And that's where this whole discipline of computer vision, image recognition, machine learning is now being put into practice.
Yes, yes, absolutely. I mean, there are so many benefits to this. I mean, obviously, as soon as we're we're doing more things, we're making more discoveries on finding more ways for computers to see. We're also finding more ways for to use this to automate and to enhance our lives, like self-driving cars and like CCTVs who can identify objects and images and stuff. So yeah, the more it advances, the more, I mean, we maybe there are use cases that we didn't even think about yet, but we will be in future. Um, that that will completely change our lifestyle, but potentially. But yeah, I mean, this is definitely a space to watch for future. I mean, there will be more technological advancements, more new innovations, and with that, there will be more ways to use these benefits of these tools.
I think one of the benefits that I mean people are already seeing is in X-rays. So, when people take X-rays, it takes a couple of days to get the report of what the X-ray. Taking an X-ray is quite straightforward. You go, you sit in a machine, you get the X-ray. But a doctor has to look at it and they have to say, okay, what this X-ray means, what we are actually observing, and do you have any particular deformities, disease, injuries, etc. And that takes time. But what if a machine has a database of looking at millions of fractures, say millions of fractures or millions of cancer photographs? So you can see spots in your lungs, so white spots or black spots or whatever. And then you train the model, and that is now being applied. So what you need to tell is, say with say 80% or 90% accuracy, you can train the computer model to look at an X-ray and tell what the problem is, and a doctor can then validate whether the problem is right or wrong. So the majority of the hard work has been done by the computer, and then just the doctor just validates it.
Absolutely, yeah. This is one of the biggest advancement of AI. I mean, understanding the um,
Medical imaging.
medical, yeah, medical imaging. I mean, you feed a machine learning software through millions and millions of data points, which are previously done X-rays to train it, because in previously done X-rays whether it was a cancerous lungs or not, and then computer learns from it. And I think it was over 90% accuracy when the AI was trained with millions
Yes.
of data points, and it was able to do it really accurately. And then when you augment this performance with an experienced surgeon or a medical practitioner, their experience kind of it takes the accuracy to like 96 to 97%. So it just, yeah, I mean, AI and humans working together really brings out the highest level of percentage of success.
Yes.
So yeah, it's been done already, and yeah, that's one of the ways image recognition is used in conjunction with AI to identify various medical artifacts.
So recently, I was reading, I mean, an example where suppose you have a database of 1 million images and you want to tag them and you want to classify
Mm.
what objects are there in each of the images, and you can ask a human to do that task. But suppose you would want to do that quickly, a machine learning algorithm that can identify millions of images quickly and tag them correctly, I think it's much more useful, because then humans can be used for validating rather than tagging it, because that's a more time consuming activity. So that's where image recognition and machine learning helps play a very important role. And when it comes to the real time vision, say in cameras, especially on cars which are moving, then I mean, more and more training. So that's why you see these Google cars and Teslas and all the things always recording videos, because the more scenarios they go through, the more deeper understanding they have of the surroundings, and then it makes our lives much safer. Suppose we have to use self-driving cars in the future.
Yes, yes, absolutely. I mean, as you said, tagging images. This sounds like very what's the point of that? But this is so powerful. This could be used in such a powerful way. Understanding when the computer understands the objects that are inside an image, that basically gives them. I mean, what do you call understanding? I mean, we use this word. I understand what is in this picture, or I understand this mathematical formula. Understanding is a tricky concept. I mean, we use this word all the time. We know what we mean. But when we say the computer understands the objects in an image, obviously, it doesn't have consciousness or awareness like we do. But anything that we would do by gathering that information of a picture of a cat, the decisions we'll make, the computer is able to make those decisions. Like, if there was a real time, imaging system where, in a self-driving car where it's looking at all the cars that are coming, and then the front camera picks up a car, an oncoming traffic, and and the if the computer understands that in that image there is a car, and that car is coming towards us quickly at a certain speed, it will know based on what it understood. It will know what to do. So that's all we do. I mean, we
Yeah.
understand a car is coming to us, and we take actions based on it, based on what we
Yes.
understood. The computer is also able to do that. Yeah, it doesn't have awareness or the same understanding, the same level of understanding as we do, but it still can make those decisions, and that's what matters when you're giving it control to drive a car. To make the right decision, make the right control
Yes.
to take you from place A to place B. So yeah, I mean, it's very important for computers to understand the objects, and that's what the tagging of images do. So you can have a million picture of cats, different types of cat or different colors, black, golden, everything, different breeds, But if it understands which that it is a cat, first of all, then it will know. I mean, we could program it to do, if it is a picture of cat, then do this, or if it's a picture of a dog, then do this.
Yes.
And nowadays, I've seen that the computer, these modules have become so intelligent. Even a lot of the times, humans don't fully understand, the objects in a picture, if it's blurry or things like that. But computer does bring up results which are actually scarily accurate. When we Even when we try to do something in a computer, there are captcha tests that prove that you're
Yes.
not a robot. Over there, this is actually the same kind of exercise where you have to identify, say, traffic lights or various objects in a picture. And computers are getting better day to day. Computers are getting better and better at it, and they will be able to solve those problems very very soon. The only reason we get away with it is that when we see the picture, it's kind of chopped off in various pieces, and the those if they're chopped off, then if you identify each of those little blocks as a separate image, then you might not the computer might not realize what it is a picture of. But when all of those little blocks are put together, we can still understand what it is. But yeah, over time, even this will be overcome. So
But
this.
I mean, this is very interesting. But I'm not sure if you're aware that the reCAPTCHA that we use when we are logging in to identify whether we are a human or not is actually being used to train machines.
Okay.
So we are actually the dummies who are tagging the images. So think
Right.
think
Okay.
think of it like this. I mean, there are so many people logging in every single day, right? And there are so many million images that we need to train, but we need humans to tag them in order to tell machines what they are, right?
Yes.
So you ask machines to tag, but initially you will have to tell them what it is, then they will learn. But in order for them to learn, we need to help them see images with the tagging. So suppose they ask you to select the bicycles in the images, 6 images that you're shown. You tag, okay, these are bicycles, and then that is used to train the machine.
That is very clever, actually. Yeah, I have heard this, I think, somewhere. Basically, obviously, when you are teaching the machine, you have to tell, at the point of training, you have to tell that did they guess it correctly or not? Is it a traffic light or is it not? How would they know that
Exactly.
without having that information? So yeah, us humans are teaching them by
So
doing that.
we are training those models as we log in, and this is a form of distributed network or distributed computing of power. So you, rather than one person doing all the task, you divide it among millions of people who are logging in, and
Yes.
that way you can train the model and you can help it get better. So suppose you select a wrong image, then there is a AI telling, okay, you have actually selected a wrong image. So there are opportunities there, and you also mentioned about the image recognition, and they are getting better. And you know what? The human reaction is tad bit slower. So the reason is that suppose you are driving on a road and you have so much information. The information can be traffic signs, pedestrians crossing the road, animals crossing the road, you looking at your speedometer, you looking at your navigation on your phone or the device in your car, and then you have to look at the road and look at all these things. So there is so much information to capture. Now, with computer vision, what happens is it recognizes the traffic signs. So, suppose there is a stop symbol, there is a give way symbol, or there is a traffic light. It recognizes it much faster than you can, and then it reacts to it by, say, pressing the brake automatically without you hurting or crossing the red light. And that's where I think machine vision might become far more superior as we train them, that they will be able to react far quicker than humans even when we see the objects in the same way.
Yes, yes, absolutely. I mean, that's the benefit of anything, digitizing everything. It doesn't have awareness, it doesn't have the understanding capability as we do, but everything else, in every other aspect, they are so much faster and so much more accurate and so much more
Correct.
efficient than humans. So as soon as that hurdle is met, as soon as we make machines that are intelligent and understand things, it will be, in a blink of an eye, it will be able to read everything there is to read and, gather knowledge throughout the internet. And there will be many amazing things or dangerous things. I mean, there is always that
Yes.
risk that
We have created
what would
dangerous things, so there might be dangerous things that they are learning as well. So we have to be very careful because I think I'm not sure if you heard this is I think outside topic, but AI models GPT-3 and everything that they are being
happen.
trained now with humans, and if you tell them a lot of abusive words, they actually start learning that and they start using that in their sentences. So
Ah,
so it's kind of a very interesting way that okay, out go learn whatever is there on the internet, but there are a lot of negative, abusive things on the internet which the algorithm can learn, absorb, and use.
yes.
So we have to be really careful, and that's why there is this ethics question like, will computers be biased? AI will it be biased? I mean, I know we are talking about machine vision, but this is something to think about. Will these algorithms be biased to people who are training them and people who are not training them? Because suppose we are only showing them objects which are in a developed country, then they will be biased to objects in developing countries because they are much random, much chaotic. Say it's they recognize people who are fairer in skin tone, but then you have skin tones which are darker, so they might be biased to darker skin tones. So
Yes,
that
I
can
think I've
come in the
read.
models.
Absolutely, I think I've read an article regarding this that some of the AIs that were trained, they were, identifying darker skinned people a lot less with a lot less accuracy than fair skinned people. So they're definitely, yeah, I mean, it will do what you teach it to do. So if you give it data with a lot of fair skinned people's faces, that's what it will be best at identifying. So yeah, it's important to remain unbiased. There is definitely a need for for to look at ethical sides as you're developing anything AI. There is definitely an ethical reason, ethical need to be ethically correct as you are building. This is very powerful, and computer vision. Yeah, the technology of looking technology of being able to see is very cool, but what is it seeing and how it is being controlled, and based on that, what implications will it have in future? These are all the things to think about. So yeah, I mean, obviously computer vision is a relatively small subject, and it ties in very well with AI and other things, but you know that we still need to always think about the ethical implications of
Yes.
everything we do. And yeah, we might think it's not within the scope of computer vision, but that's not the case. Whatever it is seeing, if you are building a tool that makes computers be able to see, then you should also have control or unbiased feed of what it can see.
True,
So
true,
it
and
is.
the same applies to human beings. So when we show a computer the photograph of a human being, we normally show them able-bodied human beings. But what about people with disabilities, people without limbs, people with scars on their faces, people with burns on their bodies? How do we make computers help them recognize those deformities and disabilities and put that in our model? I think that's also very important because most of the models that we train with healthy objects, not objects, healthy beings and regular objects, but we don't teach them about unhealthy beings and disformed objects. So I think that's also quite crucial because you have to train the model effectively across all parameters. You cannot just take the positive scenarios and then just say, okay, my model is trained. But what about the negative scenarios, the error handlings, etc.? And that has to be adapted. And the other application I just thought of in image recognition, and this is the chess. So, chess is a game of rules. So, this
Mm-hmm.
is the piece looks like this, and these are the rules. But what if you can teach a computer to just look at how the pieces are moving, learn from it, and then play it without you ever telling which piece does what.
Right,
So
right,
this is
okay.
an application of machine vision or computer recognition, that you don't tell what the object of the game is. You just tell the computer to look at how the images are changing, identify what it is happening using the pixels, and then try to understand what the rules of the game are and then try to play it. And that is now
Yes.
being used in multiple models of game plays and etc. And I think there is a company from Google, DeepMind, that they are training these models. They have this model for AlphaGo and Alpha Deep. I can't remember the exact name. I'll mention that in our description. But that model, initially it was trained to calculate based on the rules, because you know, okay, if I'm a white piece or a black piece, I'm able to do certain moves when the opponent makes a certain move. So I know the rules of the game. But what if you don't teach the computer what the rules of the game are, and they learn just by looking at what's happening on the screen? And that's even more powerful, because that way the computer learns the rule by itself and then starts playing it. So it means you just have to start giving them images, define nothing about it, and the computer picks it up. And that is even more powerful, because that's how humans learn. So sometimes babies, they look at parents what they are doing and they try to imitate that and learn from it. And we are very good at it, because we try to copy what our parents are doing. We copy the sounds, we copy the actions, we copy many other things just by looking at our parents. So I think computers are getting better and better at those models as well.
Yes, yes, absolutely. And yeah, again, this is another use case. Yeah, might be entertainment, might be cool, but it could have even bigger implications when it is able to learn the rules just by looking at. I mean, I think even a human who doesn't know the rules to play chess, they would have to look at a lot of chess games to be able to really
Yes.
understand what all the rules are. But if a computer can do it because you can feed a lot of information to it very quickly, it can learn quickly as well.
Yes.
So if a computer can learn how to play chess, it could also learn how to play, how to write codes, for example.
Yes.
And then it could potentially be able to know how to write codes to create another AI. And that would probably become even, much better AI than we ever did. So, of course, there are,
I
so
mean,
many
if you
benefits and potential applications.
I mean, if you look at the big picture, we are nothing but small atoms or molecules or whatever you want to call it, or particles. Okay, particles who
Yeah.
are following the rules or the fundamental rules of physics, and those particles follow the rules of gravitation, electromagnetism, strong, weak, etc. And they follow certain rules, and those rules make us. And there is a saying that human beings are a way for the universe to understand itself. So universe created all the particles, and the particles, through all the particles, a human being arose, and now human beings are trying to understand what the particle is. Think of it like that. It's circular. So we could be the AI, but in a different form.
Of course, absolutely. Yeah, yeah. I mean, we are. I mean, we are intelligent based on all the other surrounding animals, etc. But yeah, I mean, we are calling the computer created, digitally created intelligence as artificial intelligence. But to another completely different kind of life, we are the artificial intelligence. Could very well be. There it is fascinating to think about, but yeah, I mean, I don't know. We could reach to a definitive result by thinking about this.
I think I was watching some movies, Interstellar or something, and they talk about this, that actually the pinnacle of human intelligence will be AI, because human intelligence has limits. We cannot think
Yes.
that fast, we cannot react that fast, we are emotional, we don't take into account many things, we are sometimes not logical when we take decisions, etc. But a computer can accurately take decisions. Of course, it's not emotional, and that might make it sound very rude, etc. But it can make very highly precise statistical decisions. And sometimes this contrast is displayed in movies because they say that human beings take, sometimes just because they take irrational decisions, they reach a certain pinnacle, which a computer will not, because they will measure the risk, and they will say, okay, this is the percentage of risk, so I'll not take that action. But a human being, aware of the risk, they still take that action and they make progress. So yeah, I mean, and I think what will happen is that in the future we will slowly transform into artificial intelligence. All our, the brain dumps that you can call it, will download our memories and thoughts into machines so that we can live forever in machines, and machines can last longer. The only problem with machines now is they are not self-healing. With a human body, you can heal. So suppose you get injured, you heal yourself. With a machine, you can't repair. You have to go to some place, replace the part, and then make it work. But with a human being, it's just take some medicines and you heal yourself. You build your own body part. So suppose you have self-healing electronics, self-healing chips, self-healing microprocessors, then the game changes quite drastically, because then a laptop or anything, it can last 20, 30, 40, 50, 100 years, and that will outlive human beings. And that's the time where the intelligence will take the next level. I don't know.
Yeah. Yeah, absolutely. It's fun to think about. It's fascinating, but there are a lot of unknowns, and only the time will tell all
Only
the
time will
interesting.
tell. Yes, you're right. So anyway, I think this was a good topic, and
Yeah, yeah.
thank you so much again for suggesting this. I think it's quite useful, and I'm sure that our viewers and listeners can connect to the other topics that we have discussed so far. AI, big data. So big data is related to a lot of data which machines can then use to learn. And now we are talking about a particular type of data, which is photographs and videos, through which machines can again learn. So we are trying to keep this idea that, okay, how things are all connected. So from Internet of Things, because in the future we'll have Internet of Things as well, devices that can recognize objects, that can recognize voices, etc., and make our lives much more simpler. So I think the grand theme is that don't get scared of these devices. Of course, they are capturing a lot of information about you, but they are trying to do that so that your lives can be improved and it can be enhanced.
Absolutely, totally agree with you, Amit. Yeah, my last words are also along the same lines. I would just urge the audience to just be aware of it. I'm not saying that everyone should be an expert in image processing or image recognition, but it is a new technology that is going to be embedded within all other technologies that we have in future. So it's a good idea to know about it, what it can do, what it can't do, so you can stay safe online, and also you might come up with a very cool idea for the next advancement of within this area. So yeah, definitely be aware of it, know more about it, do some research. It's an interesting topic, so you definitely like it. And yeah, with that, that was all I had to say. Thank you.
Thank you so much.
Thanks, guys.